In this session, we are going to learn about iterators and generators in Python. So basically, both these concepts are used in Python to make our application energy efficient, or in other words, these are used to consume less amount of memory in the system. So let's take a look at these one by one. So in this example, you see I have created a list, okay, fruits, and it has three elements: apple, mango, and cherry. So this is a list item. Okay, so lists are also used to, save the amount of data in the memory. Now, what we can do, we can convert this list into an iterator, and then we will see that how much memory these objects are using. So that way we will understand the difference between these two. Okay, that is the difference between the list and an iterator. So if you see line number two, fruits is an object, and then line number three, we are using an iter function to convert fruits into an iterator. So my iterator is a different object, which is an iterator, and fruits is a list object. And if you want to check, right? Um, let's say I want to, you know, check the type of these variables. Okay, so what we can do is, let me amend this, and if you simply print type of fruits and print type of my iterator, you will see that they are showing different data types. The first one is a list data type, and second is a list iterator. It is called as a list iterator because we made this iterator out of a list. Okay, if you make this iterator out of a tuple, then it will be tuple iterator. If you run it, it's called a tuple iterator. So why we call it iterator? Because these elements can be, these elements are iterable. That means we can traverse to these elements one by one. So fruits has three elements. I can traverse it by accessing the first value, second value, and third value. So these are not just one element. These are the collection of elements. That's why it is. That's why they are iterable. So whether you talk about list or tuple or set, all these are iterable. That means you can access them in a loop or something like that. Okay, but the question is coming then, why do we need iterators? So we have a list or tuple and stuff like that, but then why do we need an iterator? So basically, like I said earlier, iterators basically takes very less amount of memory because iterator won't store all these elements in the memory at once. Iterator only stores the logic or the one particular section of the memory, and then whenever we access it, it pulls the information one by one. So if you see here, I'm trying to print the size of this variable. Okay, first you have seen type of fruits, type of my iterator, then I'm trying to print the size of fruits in the memory, and then size of my iterator in the memory. So here you will see there's a difference in the memory consumption. See, the list is occupying more number of bytes, which is 64 bytes, and the iterator is consuming only 48 bytes. And this difference is not that huge because we are using a small amount of data in the list. Okay, the next example, we will see a huge amount of data, and then when we compare it, we will see a great difference in terms of memory usage. All right. So this is what iterator means. This is how we create an iterator. Okay, out of a list or tuple or set. And this is how we see the difference in terms of memory usage. And if you want to access it, okay, so let's say if I want to access list or tuple, we know already that we can run a loop and access it. But when you talk about the iterator also we can use a loop. Okay. In addition to that, iterator we can use a method called next. That means if I say print next of my iterator, it's going to print the next element of my iterator, which is fruit. So let me print or let me comment all the other print statements. Only one print is there. Now, so my iterator has what it is. It is the iterator which was created out of this fruits tuple. Okay, so when I say next of my iterator, it is printing apple, right? And I can again copy this and paste below. Then again paste below. Three times I've pasted next, next, next. It is going to print each element one by one: apple, mango, and cherry. So this is a method that comes with an iterator. All right, but now if I print one more time, now it is going to throw an error after three times. Fourth, it is showing an error saying stop iteration because there is no element, only three elements are there, right? So that way we can access this one by one. So whenever we give next of iterator, it is getting the value from the iterator. It is not, I mean, it is generating and bringing the value from that fruits and showing it to us, correct? However, if you want to access this fruits tuple or list, we can just give fruits of 0, fruits of 1, fruits of I to access the value. Okay, so the basic idea what we need to understand is fruits. When we talk about fruits, it is occupying more memory because it has to save all this information at once. However, this iterator won't save all the values at once. Iterator is just an object which we can use to iterate among the elements of whatever no iterator we are using. All right. So let's see another example of an iterator. Um, let me get this code. Okay. So here I'm having a list which is blank. Then I'm going to create a list using a loop. So I want 1,000 elements in this list. Okay. So this will run a loop for I in range of 1,000. It is going to append each and every value in the list called my list. Okay, so line number 7, I'm going to call this create list function, which will create my list, which will have 1,000 element. Okay, after that, in line number 8, what we will do is we will try to confirm that the type of my list type of my list, we will print type of it, and also we'll print the size of my list in bytes. Okay, so that way we'll get the type and size. And in line number 8, like previous example, we will convert this my list into an iterator by using an iter function. Okay, after that we will print the uh, type and size of this my iter, so that way you will be able to compare that how much memory a list having 1,000 values is using and how much memory an iterator is using. And both of these elements have same amount of, I mean, we can use both these elements to get same amount of data. Okay, so let's see if I run this now. So I'm getting type of my list is list and it is consuming 8,856 bytes. However, this my iterator where the type is list iterator, it is consuming only 48 bytes. So that is a difference between these two, and that is why it is more efficient to use iterator if we have to store huge amount of data in our application, right? So when we talk about the accessing, you can access in the same order. Like how can I access a list? I give for I in my list, I can give print I, right? So this is going to print, see all the elements it has printed. The difference is it is coming out of memory. This my list is in the memory. Okay, all the items are in the memory, and when we print it, it is coming out of the memory as it is. And same thing we can use with my iterator. We get the same result, but the advantage is my iterator is not using that much of memory. See, so whenever we use my iterator, it is not pulling the information from a collection of data. It is creating on the fly, right? When I give my iter, it is getting this value on the fly. It is not storing anything in the memory, right? But from a user's point of view, we don't care because we are getting the desired output even by using my iter or an iterator. So, so that is why it is efficient to use iterator compared to the other collections if we have to store a huge amount of data, right? So this is another example which would have given you an idea. Okay. So this is about iterator, right? What is an iterator, and then how we have created an iterator, and the difference between iterator and the other collections. Next, we will see what is a generator. Okay. So in this example, you have seen I in line number line number 9, I have created an iterator based on a list. That means I had a list before, okay, which I converted into an iterator. And once I convert into an iterator, later I can delete the list also. Then we don't need this list, right? So this is one way of creating an iterator, right? That means we can have a one-time creation of list, tuple, or set, and then we can convert that into an iterator, and then later remove the other items, and we can continuously use this iterator. That is one way of creating. The other way of creating an iterator is using a generator. Okay, so the exact same thing, right? Instead of return my list, I will give yield. So instead of this my list dot append and then giving a return statement, I'll change this and I will give here yield of I. So for generator, I have to use a keyword yield I. Now in this, so here I have to store that also, right? So I will give here, instead of create list, let me change the name as my generator, because this is going to generate all that item. My gen, here I'm going to store a variable g equals my gen. So my gen is going to create an object, generator object, and store in the variable g. Okay. Now here, if you want to see uh, the size of that, I can give g the type of g, right? So type of g and then size of g. If I give like this, now what has happened? See, it is something similar to the other function, except the fact that after every loop, it is giving an yield of I. It is not returning I. So that way, this G will have all the values. But G is not a list or tuple or anything. G is a generator. Why it is a generator? Because we have used yield function, yield keyword here. So now, if I run this program, you will see that, see, the type of this is generator, and it has occupied only 200 bytes. Okay, However, when we tried list earlier, it occupied about 800 bytes. Correct? So here directly we have generated these values and we have stored in a variable. So this is what a generator is. Okay, it looks similar to function, but then when we return the value, we give yield I. For every loop, I'm giving yield I and everything getting stored in this variable G. But then all the elements are not getting stored. The generator has been stored in G. So whenever we want the value of G, you can just loop through it or you can simply give next, right? Because this is also an iterator, right? So I can give just next of G, it is going to print, it's printing 0, right? Because first value is 0. And again, I can print next of B is going to print 1 because it is generating and giving the value. It is not pulling all these values from a memory, unlike list. At the same time, in addition to using next, I can also use loop here. I can also use loop to uh, get these values. Like if for I in G, I can print I. So I can still get the same output, you see, right? The advantage of using this is it consumes a very low memory compared to list. That is why we are learning this, that when to use generator and iterator. So again, what is the difference between generator and iterator, right? So iterator we had seen earlier. Iterator we can create by either converting list, tuple or set. Okay, or we can create an iterator by using generators. So generator can be used like this to create an iterator. Got it? So that's about iterators and generators, um, which we can use in our programming if we have to store a large amount of data. Because let's say it is millions and millions of data if you want, or let's say if you want to store a standard list of let's say prime numbers between 1 and 1000. So we can just have this generator created, instead of having a list and storing all the prime numbers between 1 and 1000. What we can do is we can generate these prime numbers between 1 and 1000 and then store in a variable. Okay, and that variable we can access anytime whenever we want, because it is using less memory and it is, compared to the other item, this is more responsive and better, better best practice of coding. Okay, so that's pretty much about generator and iterator. Please review this and let me know in case of any questions tomorrow. Thank you.